Hello everyone, and welcome to the PV Technology Productive Use in Rural Environments webinar. This expert training series is supported by the International Solar Alliance, Clean Energy Solutions Center, and Carbon Trust. Here's an overview of the training course modules. For today, we are going to be looking at module number 4, Technical Integration of Solar PV, and the focus is on the productive use of solar PV in rural environments. Here is today's agenda, starting with the learning objective, then rural environment status quo, the current state of electricity access in these rural environments, productive energy use and solar PV technology and how they're integrated, PV technology and productive energy use implementation challenges and opportunities. Chapter 5, we'll look at some case studies. And number 6 is just a conclusion and a wrap-up of the key points from this webinar. So, the learning objective. We want to understand the application of solar PV technologies in the global rural electrification context, specifically lower income countries and developing countries, and its potential use in productive energy use applications. So, to start off, let's look at the status quo in rural environments. Today, it's estimated that there are 1 billion people without access to electricity, all of which are located in the global south, and the majority of that are in African and Asian countries. When breaking down these countries into urban and rural populations, we can see that urban population electricity access is fairly well provided by the grid, the lowest being 76% in the case of Rwanda. However, if we look at rural populations, we can see that the grid-provided electricity is very low in some cases. This shortfall of grid-provided electricity is offset by off-grid solutions, such as mini-grids or solar home systems. But in some cases, there are lots of people that just go without any electricity access whatsoever. And this lack of electricity access is in low-income countries, specifically India, Nigeria, the Democratic Republic of Congo, Pakistan, etc., as seen in the diagram on the right, all of which are low-income or lower middle-income countries. So this is where the problem exists. When looking at income groups, we can see that the energy consumption in the upper middle and high income groups globally is significantly higher than those in the lower and the lower middle income groups. The major difference here being the productive use of energy consumption. So the upper middle and the high income groups use a lot of their electricity for productive uses. The low income earners use almost all of their electricity for residential or consumptive uses. And this is because there is a lack of capacity, a lack of electricity capacity for productive uses, the affordability issues, and a variety of factors that contribute to this low energy consumption in these low income groups. And what we want to do is we want to increase the productive energy uses in lower and lower middle income earning countries. Why? Because productive use activities are those that create goods and services and that enhance income potential and value. That's according to the International Energy Agency. And it's been found that these productive energy use activities stimulate socioeconomic development and increase the amount of income directed at these rural environments, these rural households. So there are very positive outcomes associated with increasing productive use activities in these rural environments. Productive energy uses are differentiated from consumptive uses. Consumptive uses, as seen in the previous slide, could be labeled as residential use of electricity. These are services such as lighting, cooking, private entertainment. Private entertainment would include watching television, charging of mobile phones, and that sort of thing. So these are very much uses that do not create goods or services or enhance the income potential of these households. They are just used to satisfy a basic need in these communities. The other use of energy in these communities is for community services, such as health or education institutions. And while these are very much necessary and fundamental to uplifting these communities and experiencing socioeconomic development, they do not necessarily enhance the income potential or the value for households in that community. So when we talk about productive energy uses, we talk about activities that create goods and services and enhance the income potential. These productive energy use activities can be separated into three main categories. So the first of which, primary industries. This is to do with agriculture, fishing, forestry, and farming. These are uses in rural environments that are at times the most accessible because of the low financial capital needed to get these underway. We can see that, for a basic solar fence to keep the livestock in, it ranges from 62 to 120 euros. However, milking machines and more advanced technologies can go up to almost 1,000 euros, which in lower income and rural poverty-stricken environments is a lot more than households can afford. But these are the activities that use electricity for primary production industries. These industries therefore feed into these light manufacturing industries, and these light manufacturing industries use these inputs to create higher value goods or to process the goods further into usable items. So we can see here grain milling, carpentry and welding, ice making, or tailoring are potential or example light manufacturing industries that are commonly found in rural environments and that are classified as productive energy uses. Those that create an income and that create a good or a service. We can see here that the pricing for these industries is at times higher than for the primary industries. The last category is the commercial and retail enterprises. This involves your standard shops, hair salons, communication, and internet providers, for example. These are industries that sell goods and services in a finished state to consumers. We can see that certain equipment, such as freezers, can cost up to 3,500 euros, which would be extremely expensive for lower income households. But there is a large range depending on what the enterprise is and what equipment is needed to run the enterprise. So these are just some examples of enterprises that are found commonly in rural environments. Now, when linking these primary activities to the grid and connecting the electricity supply with these users, we can see that for consumptive use, household and community users, for the basic functions such as lighting, radio, and phone charging, you could get away with a solar home system, or potentially a battery-linked off-grid system. However, when we start moving towards productive uses, so moving away from a consumptive use, such as those in the blue, to productive uses, the bars in green, we can see that a more stable and a higher electricity supply is needed to sustain these activities. And the difficulty for those that do not currently have access to electricity or are under pico solar or off-grid is getting from that level to an electricity supply environment that is suitable for productive uses. We can see with energy efficient devices, you can experience some productive use activities under off-grid. However, we must bear in mind that the high upfront infrastructure costs associated with these energy efficient devices is higher than that of the older technology devices, which may be more affordable for these households and these communities. So this is the dilemma that they experience. So how does solar PV technology offer a potential solution to this problem? Productive energy uses, we can see, are very well suited to the solar PV production profile. In the top right, that graph shows a rural business load profile, which would be representative of a productive energy user, such as those mentioned in the previous slides. We can see their load profile ramps up from around 8 a.m. and tapers off by 6 p.m., which is in contrast to the rural household or the domestic energy use profile, which mainly peaks in the evening time as people come home from work and they use the lighting and whatnot, and drops down during the day between 8 and 6. So we can see in terms of productive use energy profiles, a solar PV plant would be well synchronized, well suited to supplying electricity for this profile, given that solar PV produces most electricity between 9 and 5 p.m. And as such, there is a good technical and economic fit between the two. But that's not to say that there's not implementation challenges associated with these technologies. The main challenge of which is the high tariffs and the import duties, which result in a high upfront infrastructure cost for these solar PV mini-grids. And two, a lack of a proven business case. What this means is a developer would like to have a proven business case before investing in a energy project. They are reluctant to invest in infrastructure and developing a mini grid if they are not a proven revenue model to work from. So in previously unelectrified communities, developers are unsure what the demand is, what the demand profile is, and what revenue streams they can expect from their project. And as such, they are reluctant and do not invest in these mini grids. And this is the issues that are faced. High costs associated with the technology, although these have been coming down in recent years, and the lack of a business case, the lack of certainty regarding revenue streams for the developer, which makes investment in these types of technologies, in these mini grids, slow and frustrates the electrification process. When looking at a policy environment at the international level, looking at sustainable development goals, they wish to ensure universal access to affordable, reliable, and modern energy services. However, this does not look at the electricity-enabled services. So at an international level, they first want to make sure that those that currently do not have access to electricity in any form are given access to basic electricity that is affordable. The focus is therefore not on how they can take people from residential or consumptive use and move towards productive uses that generate an income and that have positive feedback mechanisms for that community. Again, at a national level, it's not been found that there are policies and plans in place to encourage productive energy use in these rural areas. The focus is still on getting universal electricity access, solving that problem before looking to productive energy use. So this is an illustration of these issues being faced by developers. It's High cost of equipment due to the fact that these developing lower income countries do not have the supply chain to manufacture the goods locally, and the goods being solar PV equipment and materials used in a solar PV mini-grid, plus the unproven business case, the uncertainty on the revenue streams to be expected from the project. These two combined to either result in no investment in these renewable mini-grids by developers, or an oversized or an undersized grid, each of these having their own problems related to it. An undersized grid will result in brownouts or electricity supply constraints, wherein there is not enough electricity to meet the demand, which frustrates the users who will not be able to use the electricity that they need in their businesses. Or if it is oversized, the investor will not get sufficient returns to cover the initial cost of the project. Neither of these cases is desirable, and this is the issue that developers face when deciding whether or not to invest in these projects. So what are the possible solutions? On one hand, we have energy users that want modern, affordable, quality electricity supply without interruptions and suitable for use for productive purposes. And on the other side, we have energy developers which need to know what revenues they can expect to earn and will the project actually be financially viable for them. And a solution to overcome these uncertainties and these issues would be to collaborate between the two. We need to make an environment that is conducive for the uptake of productive energy use and for sufficient supply of energy to support these productive energy uses. And for that to happen, we need energy developers and the energy users to collaborate, to communicate, and to coordinate their efforts together so that these problems can be overcome. Let's have a look at a few case studies in which these solutions were proposed and implemented and how successful they were at overcoming these issues. So the first case, the Minigrid Innovation Lab in 2018. This was a pilot project which aimed to provide credit to consumers, and these consumers would then use the credit to buy appliances that they could use for productive purposes. They were located in East Africa and Nigeria, and they were connected to a mini grid. And what happened was those that were given credit and those that purchased an appliance to use productively, those consumers increased their energy consumption, as seen in the two graphs down below. The darker blue trend line indicates those that had an appliance or those that were able to purchase an appliance through this credit mechanism. And the lighter blue represents those that were not able to afford an appliance or not given credit to afford an appliance. So we can see grid revenues for the developers increased by 18% in the 11 months after the appliance was delivered to the customers. And it shows how overcoming the financial challenge from the user side, at least, getting access to equipment and infrastructure that allows them to have productive uses, to increase their revenues and increase their energy consumption, which then allows the developer to increase their revenues and potentially increase the size of the mini-grid. Another mini-grid example based in Ukara Island in Tanzania. The project developer installed a mini-grid on a previously unelectrified community. The mini-grid was a 60 kilowatt solar plant with 33 kilowatts of diesel generation, all tied to a 240 kilowatt hour battery bank, meaning that the electricity should be provided throughout the day and it should be of a decent quality for use for productive purposes. The success factors of this case study were that the project developer partnered up with local nonprofits and local organizations to understand the demand and drive the uptake of energy consumption in this region. as I said previously, unelectrified and potentially not aware of the benefits that energy use and electricity could provide for them. So partnering up with Energy for Impact and Excel Hort Consult to analyze the existing production capacity, how people in the community are transported, and how they produce goods currently. Energy for Impact spoke with diesel vendors and businesses that use diesel generators for their current electricity supply and informed them about the mini grid that was being proposed and their willingness to switch over to the mini grid electricity. And what was found is that this collaboration and partnering up provided the developer with a business case, how much demand they could expect, and the revenues that they could expect to earn from the project, and from a user perspective, gave them access to energy supply that was potentially cheaper than burning diesel in a diesel generator, and was of suitable quality for them to conduct their business and use this energy for productive purposes. Additionally, the developer also sold appliances that they could use for productive purposes and increased their education on how to use the appliances, how this electricity access could benefit them going forward. Right, so it was overcoming the initial financial constraints for those without previous access to electricity, and selling them credit or selling them appliances that enabled them to actually use this electricity productively to improve their current financial position. And in conclusion, we can see that productive energy uses is a great mechanism for rural upliftment and socioeconomic development in these rural areas, as it provides a source of income for households that were previously unelectrified or previously did not have income streams. Productive energy uses are well synchronized with solar PV technology due to the load profiles associated with productive energy usage being mainly during the day, which is well synchronized with the supply of electricity from solar PV between the hours of 9 and 5. There are still major barriers to development of solar PV mini grids and for productive energy use applications in these rural areas, mainly financial and policy or a regulatory environment that enables solar PV developers to construct these mini grids affordably and therefore sell the electricity affordably, and for the users to have access to credit or access to finance that allows them to purchase the equipment they need to use this energy productively to generate an income of their own. Here is a list of our references that we used in this webinar. And I want to thank you all very much for listening, and goodbye.